than like this corn syrup.
Right. So let's see.
So now we have added water to the corn syrup. There's a layer of water and there is a layer of corn syrup.
Yeah.
And the corn syrup
Now
is
see what
more
happens.
denser than the water.
Yeah.
Yes.
That's
So
all.
right. So if I drop the rock in here, what do you guys have? Why don't you tell?
It'll go much faster here because this is more denser than this.
Yes.
And then it'll hit like this lower point,
Uh-huh.
and then it'll accelerate like
The same way as we did before.
yeah.
Okay. Let's see. Immediately it went, and then it reached here, and then now it is constant. You see, it is constant. It's slowing down a bit here, but still it is
When you
constant.
mix the both of them together, it looks like a web of like stuff.
They're more
Why is that? What is that way?
Maybe it's like because the like the water going in and then like
It's a web.
yeah, look, the water's going up like
It is a
you
zone
can-
where both exist.
if you can see the water
meet.
going up
Right.
Yeah.
like
Okay.
There's a
Let's
web.
mix it up now.
almost.
So first, let's try to take off all these things. You know what? I think we got a
It looks so big.
Oh my god.
It looks weird.
Yeah, look at that.
It looks like a spider web.
It looks like a spider web.
So we are mixing the what we are doing here.
You're mixing the now it looks like broken glass.
No, it looks like a painting.
Why are we mixing now? Water and the corn syrup. Yeah. Yeah.
Because we already tried the corn syrup.
Mm-hmm.
It
We
looks
already
like
know
hair.
how water will work.
Yeah.
Their hair.
And we tried one on top of the other.
No.
And
In
na- and now-
a single word.
Can you take
Okay,
one
you?
out?
Just one word answer.
We want to mix the we want to see like what happens if we mix them both.
No. We want to reduce the. Do you know why we are mixing?
So you want to see how it's gonna
So the
act?
thing that you were saying, one is dense, one is less dense. What we are doing by mixing it.
And now we're gonna make it like so one is
One is
less
less
dense and one
dense,
is
more.
dense.
Yeah.
Yeah, so we're gonna mix them both, and it's gonna come in the middle of both of them.
Yeah, it will become like less dense than the corn syrup, but more dense than the water. So we are just trying to make the viscosity constant
For some
the
reason,
liquid.
like
It looks like
the
a web.
The water's trying to like not go. It doesn't want to like attach to the corn syrup.
Yeah.
So it's like there. It looks like glass, like just broke. Like the way the water's just like.
Yeah,
Can
water
you
has,
take some out?
And
Can
when
you
it
take
takes
some
them
out?
Some water.
Like some of that out.
And then we'll taste it.
No, show the camera.
the corn syrup cooked.
Wait, one of the
I
coins are
don't
there.
want to taste it.
A rainbow.
Where?
Right there. Look.
Where?
You can get more stones from outside.
I can. Oh
Guys,
yeah.
can you stay back? I'm recording.
Rainbow.
I'm recording here.
We got like two.
If you want to see anything, go around and see. Don't put your head in the middle.
All right. Let's
wanna
get
see
two
the
stones.
Stay off the table.
Don't touch.
Can you take it out?
He's doing it. Be patient.
I feel like the two corn syrups and the water didn't mix, so like when you take it out, it's just clear. Why do you get to judge it? Because
Is it slimy?
he's a professional. I touched it.
Don't lean on this table. If it spills, then you have to clean it
You
up.
have to die.
And we have no tissue paper, so I'll use your shirts.
Yeah, we do.
No, there's tissue.
Now you got to donate your shirts to make it clean.
We're not donating our shirts. It's
So
right there.
so be constant on the
It's
side.
right there.
You have to be constant on your side.
Yeah, but look, it's right
No leaning on the table.
What you
Okay.
do?
Okay. Enough.
Yeah, I think
Okay.
we should do it. There's enough items for it.
I'm gonna watch through the phone.
I'm not understanding this.
It's bad.
All right, guys. Let's do this. Okay. One final
Vishnu, you
time.
can drop all the stone. They're all behind.
Yeah. You wanna drop it? All right, guys. Here it is.
Can I drop
So-
a couple of things?
Yeah, you gotta wash your hands though. Let's see. You know what? Actually, nobody drop.
I can.
This is like messy.
Can I?
No, not you. You can go home and do it. No. Okay, listen up. We reduced the viscosity. Okay, we added some water. We reduced the viscosity of the corn syrup.
Yeah. So,
So
the
now-
thing that you said is density, For liquid, actually, it is viscosity. Density is for the solid material.
Don't touch.
If it's a
Focus.
guys, what is density?
It's like how, like, you like, it's like how dense something is.
Yeah, if you go to a forest and see this forest is dense, that
There's a
forest
bunch of
was,
leaves and
yeah, it
wilderness.
means it has a lot of
nature.
shrubs or nature in there, and you cannot go through it. I mean, it is compact. It has tightly packed things in
So
there.
density is like,
Density means tightly packed, close together. But it is a solid thing. Now, what is this?
And
Is this a solid?
no.
So we cannot
Oh,
say
wait.
this is.
The
We
three
can.
states of matter.
We cannot say this is dense, right? For the liquid, if it is closely together, we call it viscous, and we define it as viscosity.
Why does that sound like some kind of alcohol or drug?
No, it's not. It's the term. It's not a alcohol or a.
That's what it sounds like for some reason.
No, that is not viscosity. That is whiskey. There's a different thing. There's a lot
I
different.
know. It's done.
All right.
But,
So
but it sounds
viscosity,
like-
yeah, viscosity is for liquids. That how much is how dense the liquid is defined by viscosity. So now what we did by mixing water and syrup, we reduced that viscosity. So we made it even. Earlier you saw goes faster in the water, slower in the syrup. Now we mix everything up. Viscosity is lesser than the syrup, but more than the water. Now what happens? Let's see.
I feel like the it's gonna be like
Let's see.
it's gonna go.
Let's do the
faster,
same
slow,
observation.
slow, fast, slow,
Who was
fast.
counting? We'll use the big stone. You did count right till 4, and he counted till 5. So it took 9
No,
seconds to reach
9
down.
seconds,
I
right?
counted 5. he
That's
counted
fine.
That's fine.
9
now,
seconds.
Now Vishnu, you'll count from 1001. We'll see how much time it takes for the bigger stone.
Let's do this one first.
We'll
to
just
get an
do this
understanding.
trial run
I
and
just
then
wanna
we'll do the
see
bigger
it,
one.
like,
Right?
Go through.
Let's see. And almost everything took like 9 to 10
And
seconds.
back, yeah. That's,
Okay?
Oh,
How long did it take?
like 2 seconds.
All right.
all right, let's
So
count. Let's count for the stone, big stone.
Can we all count at the same
So,
time?
and also, no, actually, we don't even need to count. It's like 2 seconds, 3 seconds, right? But see if it reaches a constant velocity. Okay? So it is going to accelerate at the top. See if it slows down and maintains its speed at
See
some
if
point.
it slowed anywhere in between.
Okay? Let's see.
Oh,
2
it
seconds.
like slowed like right here, and then it went a little faster.
It was
and then-
one.
Do you know why did it slow there?
Because it's like most of the like corn syrup. is-
No. That's a different topic. Anybody knows? Why does it slow right at the
Oh,
top?
maybe because of the pressure in the surface.
Yeah, what is it
area.
called? It is a pressure. What is it called? A special name for that, yeah? I don't think you know.
Do you,
What is
do
it?
you-
Water pressure.
Have you seen milk why it boils? Why doesn't the water boil and come out? Why does the milk boils and come out of the utensil?
Wait, what?
When you boil the
I don't
milk,
think they even know.
have you ever seen like milk boiling?
Yes.
It actually comes out of the utensil if you don't stop your gas. It just keeps on rising.
Oh yeah. Like
Right?
when we make
But
like like
The tea.
here.
You can make tea, kheer, or anything which has milk. It boils out. But when you do the same thing with water, it keeps on bubbling. But it
And
never
like
comes
it's
out.
like gas. Like the
It never
same
comes
as
out of the utensil.
No, it does. Like the gas comes
The
out.
gas comes out, but the water doesn't come out, right?
Yeah.
But why does that happen?
Because the
Because it just pops when it.
No.
no, the milk is more denser.
No.
Oh,
There's a different thing which is happening on the top of milk.
there's a little more sugar.
Now, what happens on the milk? What is the covering on top of the milk? Do you see? It gets something which we call as a cream, or in Hindi we call it a malai,
Oh yeah.
right? So when you heat it, that surface, there's a surface on top of it which is cool, and the milk is hot, so the surface starts getting little solidified,
Focus.
right? That makes a surface tension. That makes that whole milk container like a balloon, right? And we are putting heat from down. So what will happen in the balloon? It will start to rise,
Oh, that's.
and it's
we
maintaining.
We learned
It's-
something in this. We
Guys.
learned.
My
we
dad
learned-
Wait, let me finish it. Otherwise, we'll never finish. So what happens? This balloon is on the top. You're putting more heat. All the liquid wants to rise up, and the steam wants to go out. But the balloon is not letting you go out. So it's making the whole thing rise. And as soon as it goes out of your utensil, the surrounding is done, and then it spills out.
That-
So this is the reverse balloon here. We're not talking here. We just want to complete this first.
But
right?
that's like technically
Later.
what we did like in our club. Like,
Next time.
yeah, we did. We
You
got
put dry ice into a
Yeah.
bottle.
Okay,
Yeah.
that's enough.
So now this is happening the reverse way. Here
And
yeah.
the name for that is surface tension. Go research on that.
Okay. So
Okay.
you have to write that in your notebook. Surface tension.
Not now. Once you're done,
Done.
you can go write it. Surface tension. Research on that too. All right. Now let's put a small thing. C for the change in velocity. Change in speed. You can do that. Hold on.
You know,
I think it maintained a constant speed at this point.
It's halfway through. It just
Okay, let's do
slows a
more.
little bit
I
down.
want to.
Okay.
I
We
want
need
to.
like a tiny
do
stone
one?
now.
Can
No,
I
hold
do-
on. Yeah, everybody can do. Hold on. You do
I
it.
call this
Hold on. Watch this.
No, you had to do the other one.
All right, you do this one. Slowly, put it right there, slowly, okay? And watch the change in speed. It was here. It was
It's
here.
right at the top.
It went faster, but from here on, it was pretty much the same.
can I have it
Yeah, you
too?
can do this. Gotta wash your hands. Sticky.
Okay.
Let's see. No, this is too fast.
If it has too much of weight, it cannot go through.
slowly.
That is a good one.
You had
It
a
was like
pencil
right
cap,
here.
right?
It was here.
You had a cap.
This one.
I don't think it will go.
Let's see.
try it.
It should go
There's
go
my
down.
tab. No, I don't want to miss it. I want to do it.
You ask him. That's us.
That's his cap. You can ask him.
Like that.
It's not going to go.
It floats.
All right.
First thing.
I thought it has some weight in it.
No.
Okay, that's enough. That's
That's
enough.
enough. We can take
Hey,
it.
no, don't touch it. All right, guys. Listen, you can do this simple experiment at home yourself. Ask your parents, okay? You can easily do this experiment. Like you can change the viscosity, add water, do whatever you want. You can take oil, you can do that, okay? It's up to your parents though.
You can take honey. It's the most viscous, and see what happens.
Yeah? It's too expensive though. But
You can take honey
I know
and
what
put
you
syrup
could do.
and then put water.
I
They'll
know
not
what you
mix
could
with
do.
each other.
I
They'll
know
stay
what
in
you
their
could
own
do.
state.
Oh, yeah.
And then you put something on the top. Don't take such a big container. Get like a thinner and a longer tube so that you can actually see that in action. All right?
I know what
And
you do.
if somebody buys it, then you can bring it back here and then we can all see
If you
what
put,
was your
If you
experiment.
put the whole thing with honey, then after you're done with the experiment, you could just eat all of it.
Yeah, you can. You can put honey and water and still eat it.
Now I'm going to wash.
All right, guys, we have to write down what is viscosity,
I need a napkin.
and we need to get that back. Okay. Joshua's laces are again off.